This video is on dimensional analysis and conversion factors, and then converting between different units. So the term dimensional analysis sounds kind of scary. Sounds like a very, advanced topic, and it's not. So the definition of dimensional analysis is just a way to solve problems using units and something called conversion factors. We're going to talk about what conversion factors are in just a minute. Okay, so dimensional analysis is just a problem-solving technique that involves using units and something called conversion factors. So units, of course, are things like inches, miles, feet, liters, gallons, miles per hour, all of that kind of stuff is a unit. And then a conversion factor is our new term here today. And a conversion factor is a ratio of equivalent values. Having different units. Okay, so this sounds kind of complicated, but it's not. So an example of a conversion factor might be that 1 minute is equal to 60 seconds. Okay, and so this fits the definition of a conversion factor because it's a ratio of equivalent values, but they have different units. So equivalent values, of course, means that 1 minute is equal to 60 seconds, but the units are different, right? Minute and second. So knowing that one, we could go on and make all kinds of conversion factors. So just a couple other examples. We'll get out of time for a minute. But, something like that 1 foot is equal to 12 inches, right? There's 12 inches in 1 foot. That's a conversion factor. We could do, a metric one, which might be unfamiliar to us, but we could do that in, that there are 100 centimeters in 1 meter, okay? We could do that there are, I've lost my train of thought. 1,000 milliliters are in 1 liter. Okay, those are all conversion factors. And so we're going to be dealing with conversion factors in this discussion because, of course, the way we're going to solve these problems is using conversion factors and units. Okay, so you should have a metric system conversion sheet. And it has all kinds of conversions. The front of that sheet is all metric, and so meaning like centimeters, meters, kilograms, okay? And the back of that sheet is both metric and English units. So if you look at the back of the sheet, it's divided into length, area, speed, volume, and weight. And so that we're going to be using this sheet as we work through these problems. Okay, so let's just jump right in and do a conversion. Okay, so when we say we're going to do a conversion or we're going to convert something, it might look something like this. Let's see, let me come up with one. So, and these can be presented to us in all kinds of different ways. So let's do, let's say the distance between, 2 points is 4.5 kilometers, okay? And since we don't think in kilometers, we want to know how many miles that's equal to. Okay, so this is a conversion problem. The question could also be presented very differently. It could say, 4.5 kilometers is equal to how many miles, or how many miles are equal to 4.5 kilometers. It could be presented in lots of different ways. So this is how we're going to solve these problems. And we're going to solve every single conversion problem like this, because even though some of these are fairly easy when we get into more advanced chemistry, and even more advanced just these types of conversion problems, it's so easy to set these up in the same way. So what we're going to do is rewrite the number that we were given with the unit attached, and then we're going to draw a kind of like a crossbar. okay? So the goal here is to change kilometers to miles. So this is like a fraction, and so my thought process is if I want to cancel out kilometers, right, where in my fraction would I put kilometers so that it cancels? Would it go in the numerator here, or would it go in the denominator here? Okay, and to cancel with, I'm going to erase those, to cancel with the kilometer that's already there in the numerator, I of course have to put it in the denominator, okay? So of course the goal is to get rid of kilometers, and I'm trying to convert into miles. So I'm going to put miles up here. Notice I haven't put no numbers in here yet. So now I'm going to go to my conversion sheet because I don't know how the mile and the kilometer are related, and that's why we have a conversion sheet so that we can check on that. So if you go to the conversion sheet and you look on the back, and this should be under length, let's see. So I actually see two different ones, and so I'll just pick. If you look, you should see where it says 1 kilometer equals 0.62137, and it keeps going, but I'm going to cut it off there. Miles. Okay. Now I didn't memorize that. I looked it up on the conversion sheet. Okay, that's exactly what it says. 1 kilometer equals 0.62137 miles. So I'm going to use those numbers and insert them into my fraction. So it says 1 kilometer. So where I put kilometer, I'm going to put a 1 because that's what my conversion factor says. It says 0.62137 miles. So where I put miles, I'm going to put that number. Okay? And then this is just like dealing with fractions, like I'm multiplying fractions, okay? So in this case, I have 4.5 times 0.62137. So of course we'll get a calculator. 4.5 times 0.62137, and I get 2.796 and some change. I know everybody's going to ask, where do we round to? We'll deal with that in a later video because it's actually another topic of discussion. Now, technically, that was 4.5 times 0.62137, and that's this number. It's still technically over the number 1, but of course, anything divided by 1 is the number that we just had. So I'm going to ignore my 1. And of course I need to put my unit on there, which is miles. So here's my final answer, that 4.5 kilometers is equal to 2.796 miles. Okay, so that's a conversion. Yeah, so we're going to set these all up like that. And I'm going to do another one here, but I'm going to leave this up here because I want to show you something about this. Okay, so we're going to do almost exactly the same type of problem, except this time I'm going to say I have, I don't know, 8.25 miles, and I want to know how many kilometers that's equal to. So this is a very similar problem to what we just did, except it's reversed. I was going from kilometers to miles last time. This time it's miles to kilometers. Same way. I'm going to write my number down with my unit. Okay, draw my crossbar. I'm going to ask myself, if I want miles to cancel, where will it go? Of course, it's on the bottom. Okay. I left my conversion factor up here because it's the same one. I'm going from miles to kilometers. So kilometers would go on the top. And I'm going to follow that same thought process that if in my conversion factor it says 1 kilometer, then I'm going to put the 1 with the kilometer. So all I'm doing is matching it up. And then of course the 0.62137 miles is going to go with miles. Oop. Oh goodness. Don't know how to get rid of that. Okay, so here we go. So 0.62137 miles. So you notice that my conversion factor is kind of flipped upside down this time, it doesn't matter, okay? That's perfectly fine. So then how do I evaluate this? Well, technically, I would take 8.25 times 1, but of course, that's just going to give me 8.25. But then this other number is on the bottom of the fraction. So of course, when something's in the denominator, I'm going to divide. So what I'm essentially doing is 8.25 divided by 0.62137. Of course, I need a calculator. And we get something like 13.28. My unit that remains is the kilometer, and that's my final answer. Okay? So this is an example of a conversion. So let's do another one. I guess I could have just erased my whole my whole sheet here, but whatever. Okay, so let's do one like this. Let's say we have 2.4 miles, and I want to know how many inches are in 2.4 miles. Okay, so same way, I'm going to put 2.4 miles, draw my my crossbar. I need miles to cancel, so miles will go on the bottom, and inches would go on the top. Miles will cancel, okay? Now, you can go to your metric sheet, okay, and you're looking for the conversion factor that relates the mile to the inch. So it should be under length. And so if we start looking for the mile to the inch, you'll notice that it's not there. And that's because, in this case, there's kind of a middle unit that comes between the mile and the inch. So in this case, I'm going from miles to inches, but there's somebody in between. I can't go directly because it's not on my sheet. So instead, what we're going to do is look for a path. So can I go from the mile to something else that will then let me go from that something else to inches? And so the middle unit here is the foot, okay? And we're gonna get better about kind of defining this path as we progress through these problems. So in this case, I have to erase something that I've done because I'm actually not directly going to go from miles to inches. I'm first going to go to feet, okay? So if I look on my paper, I see that 1 mile, I'm just gonna write it down here, is equal to 5,280 feet. And some of you may have known that, okay? So I'm gonna do the same thing. My paper says 1 mile. So where I wrote miles, I'm gonna put a 1. And where I wrote feet, I'm gonna put 5,280, okay? Now, if I calculated this problem right now, okay, and I was going to be done, my answer would be in feet because that's the unit that remains. And while that's okay, it's not the answer to my finished problem because, of course, we wanted it in inches. So I'm just going to keep going. I'm going to continue my crossbar and just extend this problem. So now I'm looking to get rid of feet. So feet will go on the bottom. And I'm looking to convert into inches. So feet cancel. And then you hopefully don't have to look this relationship up, but if you did, it's there that in 1 foot there are 12 inches. Okay, and now look, miles have canceled, feet have canceled, and I'm left with inches, and so I should be done other than just doing the math for this problem. So in this case, the numbers are all in the numerator other than the ones, so that means I'm going to multiply. So this number is going to be rather large. So 2.4 times 5,280 times 12, it's going to give us a big number. I can barely fit it in here. 152,064 inches is my final answer. Now that's a big number, and you should kind of ask yourself, does that number make sense? And it does, because think about how small an inch is. There's going to be a whole lot of inches in 2.4 miles. So this problem does make sense, or the answer, I'm sorry, does make sense to us in this case. Okay, so let's do one more. And then we'll save the harder conversions for a different lesson. Okay, so let's do one that we might have to look for a little bit. We'll do something that we're not familiar with. So just give me 1 second. Okay, let's say I have 4,000 kilograms, and I want to know how many short tons that is. Okay, I don't know what a short ton is. I don't know if you do. So this problem is one that it's kind of helpful to have these conversions so that I can look at and figure out how to solve this problem. Okay, so again, same thing. I'm just going to start with 4,000 kilograms, set up my crossbar. Okay, but of course this time I don't even know what a short ton is, so I need to start looking for some conversion factors on my paper. So of course kilogram is a weight, so I'm under the weight category, and I'm trying to get from kilogram into short tons, but we don't know if we can do it in one step. So I start looking, let's see, when there's kilogram to gram, kilogram to pound, kilogram to ounces. Okay. So, but there's the short ton, second from the bottom. It says 1 short ton is 2,000 pounds. Okay, so if I know I want to end up with short ton, I know I can get there if I have pounds, right? Which in pounds is LBS. What a silly abbreviation for pounds. So, so the question now is, can I get from kilograms to pounds? And I can't. It's actually there twice. You see that 1 pound is equal to 0.45 kilograms, or 1 kilogram is equal to 2.2 pounds. Those are actually the same conversion factor, and it doesn't matter which one we use. So my path, so to speak, is going to be the kilogram to pound, and then the pound to the short ton. So kilogram to pound, my kilograms will cancel. I go to my sheet and I look up. So let's see, let's just pick one. So the first one I saw was 1 pound equals 0.4539, and so on and so forth, and I'm going to call it done. Kilograms. So again, you're just filling in the numbers with what unit they are in the conversion factor. So 1 pound, is 0.45 blah 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 kilograms. Okay. So I've done that. I'm now technically in pounds, and I don't want to stop because I'm not in short tons. So I'm going to keep going, and I want to get rid of pound. So put it on the bottom, and we'll put short ton up here. And I go to my sheet, and my sheet says that 1 short ton is equal to 2,000 pounds. So again, 1 short ton is equal to 2,000 pounds. And now I'm in short tons, and I should be good to go. So now this presents an interesting problem here in terms of how to solve this. So let me get rid of a couple things at the bottom so we can just talk about that. Okay, so the interesting thing with this is I have 2 numbers in the denominator that I have to deal with. So most students, I think, prefer to solve these problems this way. And so, let me move this up here. So, so one way to do this is to multiply all the way across the numerator. So of course you get 4,000 times 1 times 1, which would just be 4,000. And then I would multiply across the denominator. So 0.45359 times 2,000 gives me 907.18. And then of course I would just divide those 2 numbers to get my final answer, right? We don't ever report anything like that. So it would be 4.4 with rounding, we'll say 1 short tons. Okay. So the other way to do it is, and this is how I do it on my calculator, but this is completely up to you. I just proceed from left to right. And so what I would first do is my 4,000 divided by this number, okay, because it's in the denominator. So if I do that, I get 4,000 divided by 0.45359. And if I hit enter, I get something like 8,818 is what my calculator says, okay? But then this second number is also in the denominator, which means I would have to divide, and that's where students sometimes make a mistake. They try to multiply, and that will give you the incorrect answer. So if you're going to do this kind of left to right like I do it, you would take 4,000 divided by this number. I always hit enter or equals because it gives you that answer to this part of the problem, okay? And then because 2,000 is in the denominator, you would divide again. And if you do that on the calculator, you get the same thing as what we got doing it the other way, by multiplying across the numerator and across the denominator, okay? So it really doesn't matter as long as you are following the rules of, calculator usage when you are solving these. So this is just the first example of how there's always more than one correct way to solve something, and this is a great example of that. So this was an introduction to conversion factors and dimensional analysis, and we will do some more in-depth problem